Okay, guys. So we are, I don't even know what day we're up to. What is it? Day 4, Unit 11, Day 4. So this is going to be basically inverse functions will take 2 days. So we'll do Day 4, Day 5, then review, and then test. So we're going to talk about inverse functions. And to find the inverse of an ordered pair, all you do is just switch the x and y coordinate. And I'll write that out for you. To find the inverse of an ordered pair, switch x and y. David?
You're switching it. So the inverse of 1 negative 1 and negative 1 1.
Yeah, we're going to do it. Okay, so let's say I gave you a relation. So I'm saying I have set A, and it contains the points 1, 2, 3, 0, and 4, negative 1. And now let's say I want to find the inverse of this relation. The way we represent inverse is the negative 1 on top of the set. So this is, you'd say, oh, A raised to the negative first power. No, it's the inverse of A. This reads the inverse of A. Yes, exactly, just like the matrices. So what we're going to do is if we're finding the inverse, we take each ordered pair and we just switch x and y. So now we're going to have 2, 1, 0, 3, negative 1, 4. So someone tell me, what was domain of A? So what was the domain of relation A? Arish? 1, 3, 4. Isn't domain our x coordinates, right? Can somebody tell me what is the domain, oh sorry, what is the range of A? Somebody besides Arish. What's the range of A? Aditya, thanks.
Oh, 3. Is it 2, 0, and negative 1?
2, 0, negative 1. You got it. All right, now answer this. What is the domain of the inverse of A? What's the domain of the inverse, Matt? 2, 0, negative 1. Someone different tell me, what is the range of the inverse? Rach? 1, 3, 4. All right, somebody make a connection for me between the domain and range of the original versus its inverse. Tejas?
The domain of the regular is the same as the range of the inverse.
Good. All right, the domain of the original is the range of the inverse, and the range of the original is the domain of the inverse, always. Doesn't that make sense since you're switching the x and y coordinates? All right, let's write that out. So you have that because that's going to come into play when we get more complicated. Domain of the original becomes range of the inverse, and range of the original becomes domain of the inverse. Okay, so I want us right now to we're gonna find the inverse of something I'm going to plot right now. So I'm gonna plot a parabola. We're gonna be centered at 0, 0. This is point C is 0, 0. And then I'm gonna have 1, 1, which is point D. I'm gonna have negative 1, 1, which is point B. And I'm going to have 2, negative 4. I'm sorry, 2, 4, not 2, negative 4, 2, 4, which is point E. And I will have negative 2, 4. Oh, I only went up 3. Which we'll call point A. So we have a parabola. And this graph is h of x. Guys, I need you to stop. You're being very distracting, and it's rude. Arish, that doesn't mean you turn around and keep whispering. Okay, so now before we do anything else, I want to talk about h of x. I want to discuss our domain. Let's talk about our domain of h of x. Anybody know, looking at the graph, what's our domain here? David? You got it. We could write it in interval notation, negative infinity to positive infinity. And then let's also talk about our range. Can somebody tell me what is the range here? Dylan?
0, infinity.
Good. Is 0 included or not included? So it's bracket 0 to positive infinity. All right. Now what I want to do is I want to sketch the inverse of h of x. I want to sketch the inverse of h of x. All right. Well, for basically our purposes here, for all we've learned so far, what do we do to get the inverse? We take our coordinates and then what do? Flip the x and y. So there's going to be a more productive way to do this. Oh no. But let's just do it now. So we're going to do the coordinate for A was negative 2, 4. So the inverse of A will be 4, negative 2. The coordinate for B was negative 1, 1. So the inverse of B will be 1, negative 1. Let's keep going. C is 0, 0. The inverse of C will still be 0, 0. D is 1, 1. The inverse of D is still 1, 1. And last but not least, we have E is 2, 4. The inverse of E is 4, 2. I'm going to go ahead and I'm going to plot these points to see what it looks like. So we have A is negative 2, 4. One, 2. Oh, sorry. A is 4, negative 2. 1, 2, 3, 4. 1, 2. So there's our inverse of A. And then our inverse of B, where are we at? 1, negative 1. And our inverse of C is still 0, 0. Oh, my whole graph got shifted, didn't it? Nobody was going to tell me this? Oh, no. This is making me sad. All right, are you guys graphing? Gotta get back. I'll get it back. When did my graph shift? That's not the graph.
Yeah, I thought I was confused. It said 0, 0. To be honest, I didn't even know.
There we go. All right. Do this again. All right. 1, 2, 3, 4, 1, 2. 1, negative 1. 0, 1, 1, 2, 4, 1, 2. Oh, oh, that one got messed up. What was my E? 2, 4, 4. Inverse is 4, 2. All right, here we go. Just ignore that little red dot up here. This is a blue dot. Okay, so let's talk about this. Someone tell me, what is the domain of our inverse? What is our domain? Looking at the graph, what is the domain of the inverse? Matt? Good. So the domain of the inverse is going to be 0 to infinity. Wasn't that the range of our original? All right, somebody tell me, what is the range of our inverse? David? Good. It's negative infinity to infinity, which was the domain of the original. Is that a coincidence? No. Okay, remember, when we have a graph, the original and its inverse, their domain and range switch. Now think back to geometry. This was a reflection over a line. Does anybody know what this is a reflection over? Aaron?
Wait, I didn't understand.
Matt? This is the reflection over the line y equals x. This was a reflection over the line y equals x. And that's not a coincidence either. Anytime you have an original and you take the inverse, it will always be a reflection over the line y equals x. Always. All right, so let's do some real problems now. No, this was just visuals to show you. Just so you understood what was going on. Okay, so now let's figure out how are we going to find the inverse of a function algebraically? Because there's no way we're sitting here plotting all these points and just switching x and y. That's not realistic. So what are we going to do? To find the inverse of a function, first, replace f of x with y. Then we want to switch x and y, solve for y, and then lastly, replace y with the inverse function. Okay, very special note here, very special note. Not every inverse is a function. Not every inverse is a function. So what do I mean? just because you start off with a function does not mean the inverse is a function. And the parabola was a perfect example of that. Once you write this down, I'll go back up to show you. So look at our parabola. All right, our inverse was our original was a function. Doesn't a parabola pass the vertical line test? Our inverse, which is in red, wouldn't that fail the vertical line test? All right, so just because the original is a function, its inverse is not necessarily a function. It can be a function, but it does not have to be a function. Yes.
Okay, so then if it can't be a function, then how do you solve for algebraically?
You could solve for anything algebraically. Look, we're going to show you.
I think I missed that day.
No, I didn't show you this. This is the first time I'm showing it to you. I've never showed you this before. Just stay with us. Just stay along. Yes.
So if something isn't a function, if you think the inverse could be a function?
If something is not a function, can its inverse be a function? Sure. Yeah, because the inverse of this would be the blue, right? Okay. Let's start. I'm going to have you, let's do our first example. I want you to find the inverse of f of x. So the first one I'm going to have is f of x is equal to 3x plus 5. What is this? A line. Whenever we're doing these problems algebraically, before we switch and start doing all of that, I want us to figure out the domain and range of the original and the inverse. So let's find the domain of the original. All right, what is the domain of f of x if it's a line? Claire? You got it. Negative infinity, positive infinity. Can't you all visualize that, right? It's a line. It's going on forever. All right, what about the range of f of x? So remember, it's a line. So what is the range? The infinities, exactly. Negative infinity to positive infinity. Aaron, you're not paying attention, and you need to pay attention.
Stylist, I'm trying to find it.
All right, we're going to need to separate. You all can't sit next to each other. Go back to Tejas.
Yeah, I was trying to find it.
Okay, so now before we figure out the inverse, we need to determine the domain and range of the inverse because that is going to determine how things look. So now let's find the domain of the inverse and the range of the inverse. All right, you all tell me, what is the domain of the inverse? Aditya.
Positive infinity, negative infinity? Or, wait.
Same thing, but always the negative first, right? Negative infinity, positive infinity. And what about the range of the inverse? Same thing. Okay, because remember, the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. In this scenario, is it changing anything for us? No. In certain scenarios, it will change things, which will completely alter how things look. It will completely alter how things look. Okay, so now let's go ahead and find the equation. So I'm going to say y is equal to 3x plus 5. In my steps, what did I say to do? I said take the x, take the y, and do what with them? Switch them. So I'm going to have x is equal to 3y plus 5. After you switch your x and y, what you want to do now is you want to solve for y. So you've switched them, now you solve for it. So how do I solve for y? I'm going to subtract 5 on both sides. So now I'm going to have x minus 5 equals 3y. And what am I going to do next? Divide by 3. So now I'm left with y equals x minus 5 over 3. And your very last step is to replace y with the inverse function. And you guys all agree, you don't have to write it like this, but I hope you all agree this is 1/3 x minus 5/3. Do you all know this is the same thing? Right, so the inverse of a line was or is a line. The inverse of a line is another line. The inverse of a line is another line. Now, I just want to show you in Desmos what this looks like. So my original function was y equals, what was it, 3x plus 5? All right, and then my inverse function was 1/3 x minus 5/3. Well, you can't, oh, there we go. Do you guys see? I know I don't want to, because if I move anything, I'll stop recording for Kenny. But do you guys see? It's, again, a reflection over the line y equals x. Right? Are our domains and ranges fitting to what we found it to be? Yes. All right, so now I'm going to step it up a little bit and make it a little bit more difficult, because now the domain and range or domain and or range will affect how the graph looks. So let's go on to the next one. So now I'm going to tell you my original function is f of x is equal to the root of x plus 3. What does this look like, Dylan?
No, it's a shooting star.
It's a shooting star. Has the shooting star been shifted? Yeah, where has it been shifted? Up, down, left, right? 3 units to the left, right? We all know what this looks like. Right, I want to find the domain and range of this function. If you visualize it, you already know what the domain and range is, right? If you can visualize what's happened here. So let's find the domain of f of x. All right, if you can't visualize it, what are you going to do? You're going to say, okay, well, this is a radical, so it can't be all real numbers. So we know the radicand must be what? Because of it can't be imaginary. So we know the radicand must be positive, which means what? Greater than or equal to 0. So do we agree our domain is going to be x is greater than or equal to -3? All right. So x such that, I'll just do it this way since it's already written. That's our domain. Now let's talk about our range. For the range, you need to get a visual, right? For the range, you need to get a visual. So we know we shifted 3 to the left, and it was like something like that, right? So you tell me, what's the range of this? Aditya? You got it. Interval notation? Absolutely. Okay, so now, very important, let's do the domain of the inverse. Well, isn't the domain of the inverse the range of the original? So now my domain is going to be x such that x is greater than or equal to 0. And what about the range of the inverse? What's the range of the inverse? Aditya?
Y is greater than or equal to -3.
Okay, this is going to affect things. All right, so now could we work on the algebra portion of this to find the equation of the inverse? So I'm going to take y equals the root of x plus 3. And what did I say to do? Take x and y and do what with them? Switch them. So I'm going to have x is equal to the root of y plus 3. But now I need to solve for y. How am I going to solve for y? I'm going to start off by getting rid of the radical, so we're squaring both sides. So we're going to have x squared is equal to y plus 3. What should I do now? Subtract 3. So y is equal to x squared minus 3. So the inverse function is going to be x squared minus 3. What is x squared minus 3? Not to the right. No, not to the left. Down. All right, x squared minus 3 is a parabola that has been shifted 3 units down. But this doesn't make any sense. How can the inverse of a shooting star be a parabola? Didn't we say an inverse is just the reflection over the line y equals x? So shouldn't the inverse of a shooting star just be a shooting star in a different reflected position? Right? It is. It is a reflection, because what have we not considered right now? The domain and range of our new inverse. All right, are you ready for this? I'm going to sketch it for you to show you. Okay, so our original, which I will write in sketch in blue, what was it? The root of x plus 3? Was that what it was? Okay, so then we're 1, 2, 3. When does it hit the, I don't know. I'm just going to do a quick sketch. I'm not going to worry about the y-intercept right now, just to give you a quick sketch. All right, so then we had the inverse, and the inverse was f negative 1 of x equals x squared minus 3, but the domain was, do we remember what it was?
It was such that x is greater than
Yeah, greater than 0. Greater than or equal to 0, right? Yeah, I know. And the range of the inverse? Negative 3? Okay. So I'm going to sketch the full parabola. So the full parabola is x squared minus 3. So we said it's a parabola 3 units down. So it looks something like, I don't know, something like that, right? I'm really off because I didn't actually do points. It's just a quick sketch. But now, if I erase based on my domain, they're saying x has to be greater than 0. Well, everything that x is greater than 0, isn't that I'm erasing everything to the left of the y-axis? So this gets erased. Oop. Could do a better job here. Okay. So that got erased. Now let's look at our domain. Y is greater than or equal to negative 3. Are we okay with our domain here? Yeah. Isn't now the inverse of a shooting star, the shooting star, another shooting star? So do we see what a big play domain and range have in these inverse functions? Okay. Do I have time for one more?
No.
Okay. We'll stop here.